Hello. So I wanted to make this video today because I'm usually a fan of John Stossel. I think he is a very warm presenter. I think he usually has some good guests on, and you get to hear some good takes. However, his recent video about climate change myths and debunking seemed a little out of character for his channel. There were just some inaccuracies, and it was a little clickbaity. So I wanted to go into this. I'm not really a professional on climate change. I work more in pharmacogenetics. I just got my master's in pharmaceutical science, working on my PhD now. And I wanted to take this opportunity, especially because I'm kind of naive and objective, to really look through these claims and go through the process. If these claims are robust and scientific, then I should be able to reproduce them. So the video kind of hinges on this guest that Stossel has on, Linnea Lukin, and she is a research fellow for the Heartland Institute. Now, if you don't know anything about that, you can go to their webpage. And the thing about these institutes, as opposed to more independent or, say, academic establishments, is that these are literal think tanks. And what that means is that they're politically motivated, perhaps biased to come up with a certain conclusion in order to get funding from their supporters. So their mission, they have a mission, and it's not to tell the truth, no matter who likes it or who doesn't. It is to discover, develop, and promote their ideology. They actually have quite a peculiar history. So the Heartland Institute is right-leaning, and what is quite peculiar about them is that they were actually trying to cover up the negative health impacts of smoking. Like, it's literally on the Wikipedia. You can see that Philip Morris in the 90s used them to go against their smoking bans, but since the money dried up there, now they switched to focusing on climate change denial. I'm, as I said, not really too in depth with climate change models and stuff, so I thought this would be a good opportunity, at least, to learn for me. But if we go to Lucan's profile here on LinkedIn, I'm very tempted to add her on LinkedIn. You can see, in terms of her experience, she's not really a researcher. I mean, research fellowship, you would think, would mean this person is doing like experiments or science things. Really, as you can see, when she was an intern, she's communication. She's really a propaganda figurehead. She doesn't have any scientific background. She majored in petroleum engineering, and is peculiar why she left that field where you can make like hundreds of thousands of dollars a year and do like oil assays to work for, or to work, I guess, in a journalistic job and talk about climate and environmental policy. It's just kind of weird. Hopefully she's getting paid a lot of money to be thrown through the mud. But as I said before, the Heartland Institute is not objective, and they are incredibly biased. So before you even hear what she has to say, you already know what the outcome. They are more likely to tell you what you want to hear to generate support or raise revenue, rather than tell you what is right. Um, there's a huge conflict of interest, basically. So the first part of the video, they have geophysical research letters. They're citing this to show that one of their claims I'll get into on the next slide. But how these journals work is scientists will do their experiments and package them into brief summaries or detail how they did it and show their claims. And there's different ways you can publish your results. So what I have here is the impact factor of the journal, which is 5, which means that not a lot of people in geophysics are reading this. So this isn't really a breaking study. This is further supported by it only has 4 citations, so it's not like an earth-shattering thing. But this is used by senior oceanographer at the University of Washington, Jinglun Jiang. He's a senior principal oceanographer. I thought that was a pretty cool title. But getting further into what they're talking about with the paper is there's a screenshot here that no new record low summer ice extent has been observed since 22. They're talking about the melting of sea ice, and you can see it directly in the article. No new record low summer ice extent has been observed since 2012. I thought that this was incredibly misleading, especially because it's 2025 now, and the data set that they have ended in 2015, so you can't really extrapolate what happened in 10 years from this. And also, correct me if I'm wrong, but they got that statement from this paper, but it really comes from another paper from 2020. So this is leaves some to be desired. But what I did learn about was there's a sea ice draft, which is the proportion of like an iceberg that sits below the waterline. And so if the volume is decreasing, it could be because the water is warming and melting the ice cube. I'm not exactly sure why this is so pertinent to rising sea levels, because an iceberg is floating in the ocean. So if it melts, it doesn't contribute to rising sea levels because it's already displacing the water. It's like if you have a cup of ice water and the ice melts, your cup of water doesn't overflow because that volume is already displaced. But just because I'm into the data science and machine learning field, I wanted to take a look at their actual model for looking at the sea ice draft change. So they're using what is called a linear regression model. So this is just plotting the output from their model to observe sea ice draft. So they're trying to see how well they can estimate that. And they're reporting this metric called an R squared, which is how well their model can explain the variance in the observed data. And it's sitting at around 80% or zero point 0.8. And I thought that this was kind of not really at the highest level of rigor. You have another metric in linear regression modeling called the mean squared error, which shows how well the model can, or how much error there is in the prediction. So this could be because their model could be overfit, which is a phenomenon where you describe something way too succinctly, and your model can't be generalized to other scenarios. So without that metric, it's really hard to determine that. Also in B, they're trying to show that their model can predict the data, and not only is this graph kind of ugly, but as you can literally see as time progresses, their model gets less and less accurate. The spread of the data, or the deviation in the actual data, is flowing out of the graph. Meanwhile, their model is kind of concentrated in the middle, which is kind of hilarious. I'm not actually sure how that got published without some more proofreading. Like, you generally want your points to be inside of the graph, but I shouldn't be picking on them too much. Um, but the point is that they're using this model to predict how the sea ice draft volume will decrease in the next couple years. So, can they predict the next 5 years? You already know that it doesn't really show the variation of the actual model, and it's, say, 80% there in terms of accuracy. So, it just kind of. Their, their model shows that there's no change since 2015. So, their model kind of sucks at predicting the trend. But what's dishonest about the video is that I believe they're referring to this model to say that there is no change in the sea ice volume. Can't really base a descriptive or trend that's happening right now with a model. Like we should have the data. You can find more accurate data, which is interesting because later on in the paper, or in the video, sorry, Stossel puts out this average annual Arctic sea ice, where the volume in thousands of cubic kilometers, whatever. So it has been largely stable. They're showing that it's kind of plateauing at the bottom, which is very not that's just not how you do things. You want to see like a larger trend line. There could be deviations or error in the data, so it's kind of hard to make a prediction just by slapping the line anywhere. So this is the actual graph that they cited, and you can see that there's a very clear trend line in a negative fashion here. So as time progresses, ice volume decreases, and if they had shown the actual trend line or how the data is trending in terms of error, they wouldn't have been able to make the claim that they do. Also, this is coming from the Polar Science Reset or Science Center out of I think the University of Washington. And in the actual data, they say 2024 finished with an annually average sea ice volume that was the fifth lowest on record. So, if you do go beyond like 2020 and get more into the now times, it is decreasing. So their cartoon is very misleading, and their trend line shows that the volume is actually still decreasing. I believe that in the video they only link to this graph. It's like they copied the image. They didn't send you the actual article, maybe because it debunks their own claim. I thought that that was very dishonest, actually. So now this graph here is hilarious. They're claiming that the loss of sea ice is so minuscule you can't even see it on a trend line. So the graph is in gigatons, and the data they cite is in volume. So how did they get that number? Someone scientific would at least explain their methodology on how they extrapolated this data. But someone without those qualifications makes no such effort. So there are linked papers on how to use the actual data and how to interpret it, but I thought it would be fun to just do my own analysis and see if I get the same conclusion. Because, again, the whole point of science is that it's repeatable. So I actually downloaded their volume data. I was looking up if I should use their thickness data or the volume data to see which one would be preferred for understanding these large-scale changes. So the data is a daily volume change, so I'm going to average the volume by year so I can just see a larger trend. I don't want the trend line to be distorted by daily noise or seasonal noise. I'm also excluding 2025 because as of this recording, we're only at April, and this could distort the data set and our trend line. So really, if you're plotting volume over time, her analysis doesn't really make any sense. So somehow she turns volume data into mass data, or as gigatons. And she also misinterpreted sea ice volume as land ice volume. So this is still sea ice. Whenever it melts, it doesn't displace any. It's already displacing water. It doesn't affect the sea levels. Her results have also not been externally reviewed, so someone with integrity would want to make sure that they're right. You don't just get results and run out to the public, because what if you're wrong? Then you have to do damage control. It's just very immature, not rigorous thing to do. So I know what you're saying. You can get mass from using the volume from the density of sea ice. So I just got the quick AI overview. So the density of ice that I used is 910 kilograms per meters cubed. And once I did the conversion, I get the same graph. Because if you change the units, the scale is different, but the trend is still the same. That's how math works. So I'm saying her analysis is dishonest, incorrect, and I really don't know how she got those numbers from the data supplied. Furthermore, then they start talking about global polar bear population estimates, and I have no idea where she got this data from. The graph itself is not cited in the paper that they referenced, and whenever I did look at the paper, most of the actual population data is, first of all, in discrete subgeographies, and it's kind of old. Some of it goes back to the 90s or is even just unknown what the actual population is or the population change. I couldn't even find on the parent website that this comes from where you get the actual data. If someone could actually find that data for me, I would be more than happy to analyze it. But her graph doesn't make any mention of different geographical areas. And it's just kind of misleading. I'm not entirely sure where she got this data from. Furthermore, then they try to link agricultural output to try to debunk that there are food shortages globally. So what they show in the video is that food output or agricultural output, an economic metric, is following a linear trend globally and has been increasing over the past 50 or 60 years. However, if you look at the output, by country that you can select, developed countries are kind of flat, and Asia and least developing countries are kind of booming right now. So, food production is stalling in developing countries and it's increasing in Asia or whatever. This is a good case where causation does not equal correlation, in the sense that developing countries or developed countries are less reliant on their domestic agriculture. They've, outsourced manufacturing, agriculture, whatever. So it's easier for them to import it. Why produce more when you can import it cheaper? Even still, this data is not sufficient to confirm if there are food shortages occurring. Again, this is another problem in their logic. They're trying to talk about these wider global trends through metrics or data that aren't really necessarily associated with it. They're kind of drawing on this false equivalency. Furthermore, then they start talking about how the greenhouse effect, or the CO2, is increasing fertilization in plants, and the plants are benefiting from CO2. NASA even says that, but Dr. Philippe Chavas says that studies have shown that plant acclimatization, or can adjust to rising carbon dioxide concentration, but their fertilization effect diminishes over time. Even with an NASA scientist, I don't know if um, we have the authority to say that. I don't know if you can make a prediction that concrete. I would say that the effect is unknown if it will persist. I would argue from, my discipline, the biological effect. So the globe was actually warmer and had a lot more CO2 about 300 some millions ago in the Carboniferous period. But, life was allowed to evolve over these long periods of times and adapt to a changing climate. If it's very sudden over the course of a few centuries, it's kind of a shock to the system, and it doesn't give evolution enough time to adjust to this new environment. So it's kind of dangerous. It's like throwing someone into the ocean and expecting them to instantaneously evolve gills. That's not really how it works. It takes a very long time to do that. Also, they're trying to insinuate that deaths from protein energy and malnutrition have actually gone down in time. And this is another instance that causation is not correlation. Declining malnutrition isn't intrinsically tied to the climate in a perceptible way. There could be other factors like, war, droughts, economic factors, whatever. And the data set is kind of peculiar that they are using. So globally, it does show a decreasing trend, but North America and Malaysia show an increasing trend, especially in 70 plus years old. And there's also a very huge spike in the Eastern Mediterranean in 2011. I'm not a economist or I'm not particularly sure what is going on here, but to me that seems very peculiar, and antithetical to the claim that they're making. And finally, they talk about coffee production and they say, okay, it's increasing over time. The world is outputting more volume, and they are trying to debunk in the video that a price increase in 2025 was related to climate change. And they're saying, oh, if you have this rising trend in production over time, then it can't be climate change as a long-term effect. So this data set I was kind of intrigued about because it's from the Food and Agricultural Organization at the United Nations. And I'm not really sure why the world leading producers of coffee like Colombia, Vietnam, Venezuela, Brazil, Ethiopia, and Indonesia are producing a minority of the world's coffee in this figure. So I'm just kind of wondering what's going on here, but they're misattributing the long-term effects of climate change to its instantaneous effects. Okay, so it's not shown over a long period of time, but what about a new superstorm? Or in that sense, they're kind of being dishonest and misleading. They're not portraying their opponent or the articles they're citing in a positive light. It's called a straw man fallacy, where you kind of make a false image of your opponent and then strike them down easily because it's fake. It's not what they're actually representing. If you read an article about why coffee prices are so high, it's because one of the world's leading producers, Brazil, had a lengthy drought in 2024, and it led to poor crop estimates for the upcoming year, as by this article, Food and Wine. And there's also other economic things you can see. You can look it up for yourself. But really, what is at stake here is that they're trying to misattribute the long-term effects of climate change to its instantaneous effects, and it's honestly very misleading